Okay, welcome back, folks. This is section 3-4, solving polynomial functions. I've split this video up into two separate files because the factoring is pretty much a review of what we did in Unit 2. So if you want to listen to that at 2 times speed and move through that, you can take some more time with the second part of the video, which is geared towards solving polynomial functions. So in the first video, the first video, we're going to talk about factoring polynomials, and then in the second video, we're going to use those factored polynomials and the zero product property to solve polynomial equations. We're also going to use quadratic form to solve polynomial equations. Okay, so there are two pieces of vocabulary that we need to remember. A prime polynomial is a polynomial that cannot be factored any further, and a quadratic form, polynomial in quadratic form, is where you can rewrite it in au squared plus bu plus c form for any numbers a, b, and c. A cannot be 0, and u is some expression in x. So basically, we have some expression that uses x, and we put that in for u. Okay, so the factoring techniques, a review from Module 2. We always check GCF first, right? Greatest common factor. We always do this first. Do this first, right? GCF, always do that first. If we have two terms, we're looking at difference of squares, sum of two cubes, difference of cubes. So everything's in ABC. If you have three terms, you're looking for perfect square trinomials or general trinomials. Either way, you're looking at the multiples of AC that add to B. And then 4 or more, we're going to be doing grouping. I know we didn't talk too much about grouping, but we'll talk a lot more about grouping for polynomials. Okay, so example 1, we're going to go ahead and factor. Remember, the first thing we always look for is the GCF. So we always look for a GCF first. And we see that the GCF here is 2x. So we're going to take out a 2x, and we're left with 8x cubed plus 54 divided by 2 is 27. Take an x out, and y cubed is left over. And then we look and we notice that this here is a sum of cubes. And so we can rewrite this as 2x times 8x cubed we can rewrite as 2x quantity cubed. 27y cubed we can rewrite as 3y cubed, or 3y quantity cubed. And remember, sum of cubes has the form, if we have it in a cubed plus b cubed, we use SOAP to rewrite it as a plus b, the same sign, times a squared minus ab, because opposite sign, plus b squared. So that's the form of the sum of cubes. So this is our a, and this is our b. So we keep the 2x out front, times a plus b, so 2x plus 3y, times a squared, so 2x squared is 4x squared, right? 2x quantity squared, minus a times b, so 2x times 3y, 2 times 3 is 6xy, always positive, plus b squared, so 3y quantity squared is 9y squared. And there's our factor. Okay, I want you to go ahead and try this one. I'm going to put the answer right over this blue rectangle in just a moment. So pause the video now. Go ahead and factor this polynomial using this pretty much the same process we did here. Okay, welcome back. If you want to see the answer, make sure to pause it so you can check. Otherwise, if you don't want to see the answer, cover up that square right now. I'm going to show you the answer right now. Okay, there we go. Make sure you pause it if you want to double check. Otherwise, we are going to move on to example 2. Okay, so example 2, again, we always check for the greatest common factor first, and we notice that we have a greatest common factor of negative 2w. So 54w to the fourth is divisible by negative 2w, and negative 250wz cubed is divisible by negative 2w. So we're left with 27w cubed plus 125z cubed. Okay, and again, here we have a sum of cubes, because we can think of this as negative 2w times the quantity 3w cubed plus the quantity 5z cubed. Remember, sum of cubes always follows the same pattern. So there's your A and here's your B. If you want to pause the video and write out the sum of cubes here, so that way you can double check it. So this is going to end up being 2w times A, 3w, plus B, 5z, times A squared, 9w squared, opposite, so minus, A times B, 3 times 5 is 15wz, plus B squared, plus 5z, quantity squared is 25z squared. Okay, there we go. I want you to go ahead and try to factor this one. Pause the video right now and do that. Okay, welcome back. The answer is going to pop up right here, so if you don't want to see it, put your hand over. There's the answer. Pause the video if you want to double check. And so, in example 3, we're going to factor by grouping. So the first thing we always check is greatest common factor. So we have 8ax, so it looks like up till now we have 4x is a common factor, and 4x does not divide out on this one here. So no GCF. There's no GCF. Okay, so now we look and we have a multi-term polynomial. 1, 2, 3, 4, 5, 6 terms. And if we look, all the first 3 terms use x, right, have x as a value, and the last 3 terms have a common factor of y. So we're going to take out the greatest common factor from the first 3 terms, which is 4x, right, 4x, and that leaves us with 8ax divided by 4x is 2a, plus 4bx divided by 4x is just b, and 4cx divided by 4x is c. If you need a moment, pause the video and double check to make sure that that distributes back so you can understand why we can factor that. Okay, next, we look here and we notice that the common factor here is y and also 3. So 3y is a common factor. And so 6ay divided by 3y is 2a, plus 3by divided by 3y is b, and 3cy divided by 3y is c. And so we notice here that this is a common factor, right? 2a plus b plus c is a common factor, so we can factor that out of the term here. So 2a plus b plus c times 4x plus 3y, which is left over. And it doesn't look like any factoring technique will help us factor further, so this is the fully factored answer. Okay, go ahead and try this. Pause the video right now. Try it on your own. Okay, welcome back. Here, the answer is going to pop up here, so if you don't want to see it, put your hand over. Here's the answer. Make sure you pause the video if you need to, and we'll move on. Okay, so example 4, we're going to factor each polynomial. First thing we look for is there's no GCF. Okay, and next, we notice there's a difference, and with the power of 6, we can rewrite that as both cubes or squares. We will always, if you have an option between the sum of cubes or the difference of cubes and the difference of squares, do the difference of squares first. So we're going to do the difference of squares always first. And so if we look at this, we can rewrite this as x cubed raised to the second power. So x cubed is my a, minus y to the 6 can be rewritten as y cubed to the second power. So my b is y cubed. And then I use the form of difference of squares. So a, which is x cubed, plus b, which is y cubed, times a, which is x cubed, minus b, which is y cubed. Okay, now I have a sum of cubes here. This is a sum of cubes. And I have a difference of cubes here. Okay, so I can rewrite this using my form. So this is a sum of cubes. So here's my a and y is b. Okay, so a is x and b is y. So we can rewrite this as a plus b, so x plus y, times a squared, which is x squared, opposite sign, so minus xy, always positive y squared. And over here, this is the difference of cubes, so here's your a and here's your b. So same sign, a minus b, times a squared, so x squared, opposite sign, plus, ab should be xy, sorry, xy, minus, so a minus b, so x minus y, and then here, x squared, because it's a squared, opposite sign plus, ab, so xy, always positive y squared. And we look here, none of these are perfect squares. We don't have any methods for factoring any of these. So here's our final factor of 4 prime polynomials. Okay, so here's the you try. Please pause it right now and try it. Okay, welcome back. I'm going to put the answer up right here. So if you do not want to see the answer, please put your hand over it. Otherwise, here is the answer. Pause it if you want to check. Otherwise, we'll move on to the next example. Okay, first thing we always look for is the greatest common factor. And so we have an a and an x, an a and an x, an a. And now we move on to b. Okay, so we know we have no greatest common factor. And we have multi-term polynomials. So the first thing we should be thinking is factor by grouping. And if we look, these all have a terms and x terms. And these all have b terms and x terms. Okay, so the greatest common factor in the first part is a cubed, because we have a cubed and a cubed and a cubed. So we take out a cubed times x squared minus 6x plus 9. If you need to pause right now to double check my work, please do so. The next thing we notice is that this isn't plus, this is a negative. So I'm going to pull out a negative b cubed. So I'm going to pull out negative b cubed. And so this becomes positive x squared. And when I pull out a negative b cubed here, this becomes a negative 6x, right? So negative b times negative 6x will be positive 6b cubed x. And if I take in a negative b cubed here, I end up with plus 9. And then you notice that these two are common factors from the two terms that exist. So we can factor out x squared minus 6x plus 9 times a cubed minus b cubed. And you notice here, 6 divided by 2 is 3, 3 squared is 9. So this is a perfect square trinomial right here. And this is a difference of cubes. So we can use both of those factoring techniques. So perfect square trinomial becomes x minus 3 quantity squared. And a cubed minus b cubed, using the difference of squares, is a minus b, remember use the same sign, times a squared, opposite sign plus ab, always plus b squared. And so we've used both factoring by grouping, then we used the perfect square trinomial, and the other factor was a difference of cubes, and we used those factoring techniques. Okay, go ahead and try this one on your own. Pause the video right now. All right, welcome back. I'm going to put the answer up here in a moment, so if you do not want to see it, please cover it with your hand. Here's your answer. if you want to pause the video and double check it. Otherwise, up next, we're going to watch the second part of the 3-4 notes. Thank you so much for listening.